The date 1524 went down in history as the first time winding watches were made. German locksmith Peter Henlein produced the first known wind-up watch in history. Clock. Who invented when? How did people measure time in ancient times? Who invented the clocks used today? In this video, we go on a historical journey on the invention of the clock. Time is cash. The word tells that time is very valuable and should not be wasted in vain. In order to use time efficiently, we plan our daily life and try to act accordingly. Clocks are our biggest helpers in this regard. Today, although we mostly track time through digital displays on mobile phones, tablets and computers, we continue to use watches by wearing them on our wrists or hanging them on the walls of our homes, schools and workplaces. So how did people measure time in past ages? How did the clocks used today come about? Let's take a historical journey on the invention of the clock. Time measurement in ancient times. Who found the clock? Before answering the question, let's look at how time was measured in the past. The concept of time, which consisted of the rising and setting of the sun and the disappearance of the stars in the sky in ancient times, began to change, especially with the settled life of people and farming. Now, animals had to be fed regularly, agricultural products had to be planted and irrigated at certain times, and post-harvest products had to be transported to marketplaces at certain times. These needs prompted people to look for different ways to measure time. Sun clock. Sundials, one of the first instruments used to measure time, were invented in ancient Egypt around 400 BC. A stick was placed on a flat surface in sundials and the length of the shadow formed by the stick depending on the angle of the sun was followed. These watches, which were quite simple in the beginning, were developed after a while and dials showing time zones were added on them. At that time, the base 12-number system was used in Egypt. Later, this system was transformed into a 6-number system based on the number 60 during the Babylonian period. 12 and 60 base systems are the basis of 60 minutes of an hour, 24 hours of a day, 12 hours of day, 12 hours of night, 360 degrees of the circumference of a circle. The biggest disadvantage of the sundial was that it could not be used in cloudy weather and at night because there was no sunlight. Water glass. It is estimated that water clocks, which were invented for situations where the sundial does not work, appeared in ancient Egypt and were later developed by different civilizations. The most common of the different types of water clocks consisted of a large vessel of water that was emptied a full day or 24 hours. There was a hole in the bottom of the bowl and lines representing the passing time in it. While the water was slowly flowing through this hole, it was understood that unit time passed when the water level reached one of these lines. The Chinese, on the other hand, used a different water clock, in which the time was determined by the water flowing from one vessel to another, filling the other vessel when one was empty. Muslim scholar Al-Jazari designed one of the most famous examples of the water clock. Elephant water clock developed by Al-Jazari. Candle clock. The candle clock, whose first place in time is unknown, was used in Japan until the beginning of the 10th century. During these hours, as the candle burned, it was determined how much time had passed by looking at the marks on the wooden stick on or behind the candle. Mechanical watches. The first mechanical clocks began to be used in the 1300s. Free fall was prevented, that is, the weights descending slowly from a certain point made the wheels spin, and these clocks could not measure time precisely. They had to be readjusted every day, as they deviated more than about 15 minutes a day. In the early 1500s, German locksmith Peter Henlein produced the first wind-up watch in history using the mainspring. Thus, there is no need to use large weights in watches. Despite not showing time precisely, people started to carry these watches in their pockets. Italian inventor Galileo Galilei discovered in 1581 that thanks to pendulums with regular oscillations, mechanical clocks with a low margin of error could be designed. 75 years later, Christian Huygens developed the pendulum clock, which deviates less than 1 minute a day. In 1762, John Harrison invented a pendulumless clock that showed the time accurately. This timepiece, a kind of stopwatch, used a balance wheel and a spring instead of a pendulum. Quartz watches. In 1927, Canadian Warren Marison developed the quartz watch. In these battery-powered watches, the time measurement was made on the vibration frequency of quartz crystals. The first quartz clocks deviated by 1 second approximately every 4 months. Over time, the margin of error in the measurements of quartz watches decreased to less than 1 second in 32 years. Since the 1980s, developments in electronic technology enabled these watches to be produced easily and cheaply. Thus, quartz watches have become the most widely used time measuring technology in the world. Most of the watches we wear on our wrists or hang on the wall today are quartz watches. In addition, quartz crystals are used to measure time in mobile phones, tablets, and computers. Atomic clocks. Atomic clocks are the most precise time measuring instruments today. It takes about 30 billion years for the most precise atomic clocks to deviate by 1 second. The idea of using atoms to measure time was first proposed by Lord Kelvin and James Clerk Maxwell in the late 1800s. Isidore Rabi demonstrated that the atomic clock could be developed by utilizing the magnetic interactions between electrons and atomic nuclei. The first atomic clock was developed by Harold Lyons in 1949. Atomic clocks are used in various technologies and scientific studies. For example, GPS satellites used for positioning have precise atomic clocks. In addition, atomic clocks are also used in scientific studies where it is necessary to measure time precisely, especially the theory of relativity. Do you think atomic clocks are the last point we can reach in time measurement, or can more precise clocks be developed in the future? Thank you for watching the video. See you in another video. Goodbye.